So we are going to do this problem. It is an example, no? The example is like this. You have two parallel plates, capacitors. The area is 10 a la minus 2. The separation between them, between the two plates, are 10 a la minus 3. And the first question say, calculate the capacitance. Well, very easy. The capacitance will be, we have seen that the capacitor is x equals 0, A divided by D. If you calculate this will give you, plug in the numbers, 88.5 picofaradius. I know because the area is 10 a la minus 2. Well, I'll do it. C is 8.85 picofarad per meters, 8 picofarad per meters, multiplied by the area, 10 a la minus 2 meters square, divided by the distance, 10 a la minus 3 meters. So the capacitance will be meter squared divided by meter is meter. With this meter we'll go and we'll take 88.5 picofarad. And this is the capacitance of these two parallel plates. So part A is already solved. What is the part B? The part B is calculate the charge when the two parallel plates are charged with a different potential of 12 volts. Then now the capacitance is the charge that you can place in the metallic conductor divided by the potential that you have. So they asked me for the charge that you can place. The charge that you can place is the capacitance by delta V. If you make the calculation, it will be very easy to find that you can find C is 88.5 picofarad by 12 volts. Picofarad by volts is coulomb, is charge. Of course, you see here, picofarad of farad per volt is coulomb. So it will be 1.06 nanocoulombs. And so the part B is done, and we found that at the difference for this capacitor of 80.85 picofarad and this and this difference of potential 12 volts, you can place a charge of 1.06 nanocoulombs. Now the part C is different. Part C, it say, if you have this capacitor, what will happen with the charge in the plates when you insert a dielectric? When you insert a dielectric when you insert, what is the new capacitance? Well, the new capacitance, C, the new capacitance, C new, will be K times the old capacitance. So it will be 2 times the old capacitance. The old capacitance was C0, 8.88.5 picofarad. So the new capacitance will be 88, 160, 176, 177 picofarad. This is the new capacitance. And why is that? Let me remember. Why is the new capacitance multiplied by C? Because the new capacitance is the charge that you place divided by the difference in potential. The charge that was placed before was Q0 divided by delta V. But delta V now, delta V is an electrical field that is diminished by a factor of K multiplied by D, because this is the new capacitance with the dielectric, the electrical field E inside the electrical is E0 divided by K. So at the end is K times C0. So this is the new capacitance, and the new capacitance correspond to a charge Q divided by the same change in potential. Oh, so the new charge Q that is here is the new capacitance by the same change in potential. By the new capacitance is the old capacitance by K multiplied by delta V. So this was the new capacitance. So the charge increase in a factor K by Q0, C0 by delta V. So the charge that you have to place to solve this problem is K times Q0. The other way to see it is like this. If you have the parallel plates capacitor and you have an electrical field E0, E3 or E0, okay? Now when you place the dielectric, the electrical field, and you maintain fixed this change in potential, you maintain fixed V sub AV, you maintain fixed. Now when you insert the dielectric here, let's say that the dielectric occupy the distance D, okay? So now because you maintain the difference in potential, dV equal E by D, if dE is smaller, you need to place the difference of potential of 12 volts here. So you need more charge here. More charge here. The new charge Q here is K times the old charge Q0. Okay, done. As a result, the new charge Q is 2 times the old charge. The old charge was let me see, 1.06 nanocoulomb, 1.606 nanocoulombs. So the new charge that is here, when you place the capacitor and you maintain the potential, the new charge is 2.12 nanocoulombs.